Hello students, welcome to our student support program for maths. The lesson will be on simultaneous equations. This is the second part of the chapter Simultaneous Equations for grades 10 and 11. In the previous lesson, we have learned what are simultaneous equations and how to solve simultaneous equations using the elimination method. In today's lesson, we will learn how to solve simultaneous equations using the substitution method. What are the steps to be used in this method? So we will consider any one of the two equations. We will make one of the variables the subject of formula. It can be either x or y, and we will label it equation 3. Now we will replace equation 3 into the other equation. So let us say that you have taken equation 1 and you have decided to make x subject of formula. So now you're going to call it equation 3, but you will replace it in equation 2. You cannot replace it in equation 1 again. And we will solve the resulting equation. Once we get the value of the unknown, we will replace it into the third equation to find the other unknown. So let us start with an example. Solve the simultaneous equations x plus y equal to 15 and x minus y equal to 3. Just as we did in the previous lesson, we will label our equations 1 and 2. Now, if I decide to take equation 1 and I decide to make x subject of formula, I will get x equal to 15 minus y, and I will call it equation 3. But as I have mentioned earlier, you decide which equation you want to work with and which variable you want to make subject of formula. So I will now replace equation 3 into equation 2. I will replace the x by 15 minus y equal to 3. I will simplify this equation and find the value of y. So 15 minus 2y equal to 3. Minus 2y will be equal to 3 minus 15, which is minus 12. Y will be equal to 6. Remember, we are solving simultaneous equations and we will have two unknowns. So once I get the value of y, I need to find the value of x. So I substitute the value of y into equation 3. X will be equal to 15 minus y, that is 6, and x will be equal to 9. Do you still remember what is the last step in simultaneous equations? Yes, we need to check if our answers are correct. So I will replace the value of x and the value of y into one of these two equations. So here, substitute values of x and y into equation 2. So the left-hand side will be x minus y, that is 9 minus 6, which is equal to 3, which is equal to the right-hand side. So it means that our answers are correct. Let us move on to a second example. Solve the simultaneous equations 4x plus 9y equal to 5 minus 5x plus 3y equal to 8. So the first step will be to label our equations 1 and 2 respectively. Now I have decided to choose equation 2 and I will make y subject of formula. So from equation 2 we will have 3y equal to 8 plus 5x. I take the minus 5x on the left hand side and I send it on the right hand side, so it becomes plus. And I need to make y subject of formula, so I have to divide by 3. Therefore, y will be equal to 8 plus 5x over 3. And I call it equation 3. Now, because I have started to work with equation 2, when I'm going to replace equation 3, I should not take equation 2 again. So I will replace equation 3 into equation 1. This means that I will replace y in equation 1 by 8 plus 5x over 3, which will give me 4x plus 9 into 8 plus 5x over 3 equal to 5. So here we can see that 3 will cancel with a 9, and I will get 3. This will give me 4x plus 3 into 8 plus 5x equal to 5. Expanding the brackets will give me 4x plus 24 plus 15x equal to 5. Simplifying, I will get 4x plus 15x, which is 19x, and 5 minus 24 will give me minus 19. So x will be equal to minus 19 over 19, which is minus 1. Now I substitute the value of x into equation 3. So y will be equal to 8 plus 5 into minus 1, because x is equal to minus 1, divided by 3, which will give me 8 minus 5, 3, and 3 divided by 3 is 1. So we will now check if our answers are correct. We substitute the values of x and y into equation 1. So the left hand side is 4x plus 9y. I replace x by minus 1 and y by 1, which gives me minus 4 plus 9 equal to 5, which is equal to the right hand side. So our answers are correct. We now move on to the third example. Solve the simultaneous equations 3a plus 4b equal to 43 and minus 2a plus 3b equal to 11. The first step will be to label our equations 1 and 2 respectively. Now I will consider equation 1 and I will make a subject of formula. So from equation 1, 3a will be equal to 43 minus 4b, and a will be equal to 43 minus 4b over 3. And I will call it equation 3. So now in which equation should I substitute equation 3? Yes, you're right. We need to substitute into equation 2. So replacing a by 43 minus 4b over 3 into equation 2, we will get minus 2 into 43 minus 4b over 3 plus 3b equal to 11. So here I will multiply all the terms by 3 to cancel the 3 in the denominator. I will get minus 2 into 43 minus 4b plus 3b times 3, which is 9b, equal to 11 times 3, which is 33. Expanding the brackets will give me minus 86. Now be careful, minus 2 times minus 4b will give me plus 8b. Plus 9b equal to 33. Simplifying will give me 17b equal to 33 plus 86, which is 119. So b will be 119 divided by 17, which is 7. Once I get the value for b, Now I need to find the value for A. So I will substitute the value of B into equation 3. A equal to 43 minus 4 times 7 over 3, which will give me 43 minus 28, that is 15 over 3, which is equal to 5. So A is equal to 5 and B is equal to 7. Let us check if our answers are correct. So we substitute the values of A and B into equation 2. The left-hand side will give me minus 2 times 5 plus 3 times 7, which will give me minus 10 plus 21 equal to 11, which is equal to the right-hand side. That is, our answers are correct. Now, there are a few questions for you to practice using the substitution method. The second set of exercises will be to solve the following simultaneous equations using either the elimination method or the substitution method. So here, you decide which method you want to use. So the first step will be to label our equations 1 and 2. I will first consider equation 1. The LCM of our denominators, that is 3 and 5, is equal to 15. So I will multiply each term by 15. This will give me x over 3 times 15 plus y over 5 times 15 equal to 2 times 15, which will give me 5x plus 3y equal to 30. So why have I done this? This is simply to avoid working with the fractions, and then I can use the elimination method if I want to eliminate one of the unknowns, or the substitution method if I want to make one of the variables subject of formula. So I call this equation 3. Now from equation 2, I will make y subject of formula because I will be using the substitution method. Remember here you can either use the elimination method or the substitution method. So making y subject of formula, I get y equal to 2x minus 1, and I call it equation 4. So I will now substitute equation 4 into equation 3. So here is equation 3 and equation 4 as well here. Replacing equation 4 into equation 3 will give me 5x plus 3 into 2x minus 1 equal to 30. So expanding the brackets will give me 5x plus 6x minus 3 equal to 30. Simplifying, I get 11x equal to 33 and x equal to 33 over 11, which is 3. Once I get the value of x now, I need to find the value of y. So I substitute the value of x into equation 4. Y equal to 2 times 3 minus 1, that is 6 minus 1, which is 5. And remember to check if your answers are correct. So from equation 1, I had x over 3 plus y over 5 equal to 2. Replacing x by 3 and y by 5, I will get 3 over 3 plus 5 over 5. That is 1 plus 1, which is equal to 2. That is our right-hand side. It means that the values of x and y are correct. A second example now. X plus y over 3 equal to 3. 3x plus y over 5 equal to 1. So the first step will be to label our equations 1 and 2. I will multiply equation 1 by 3 to cancel the denominator. So I will get x plus y equal to 9. And I will multiply equation 2 by 5 to get 3x plus y equal to 5. And these two new equations will be labeled as 3 and 4 respectively. So we will now work with equation 3 and equation 4. In this case, I can see that the coefficient for y in equation 3 is 1 and in equation 4 is 1. We have the same coefficient for y. I check the sign in front of y, plus in both equations. So remember, when we have same sign, we subtract. So I will subtract these two equations. X minus 3x will give me minus 2x. Y minus plus y, 0. 9 minus 5 equal to 4. So x will be equal to 4 over minus 2, which is minus 2. I replace the value of x into equation 3. And I get minus 2 plus y equal to 9. So y will be equal to 9 plus 2, which is 11. So now we check if our values are correct. From equation 1, that is x plus y over 3 equal to 3, I replace x by minus 2 and y by 11. And I get 9 over 3, which is 3, which is equal to our right-hand side. So it means that the values for x and y are correct. So you will have a few pair of simultaneous equations to solve using either the substitution method or the elimination method. There are also a few past examination questions for you to practice. So you can see that no mention is made of a method to be used. You decide which method you want to use, whether you want to use the elimination method or the substitution method. So students, in today's session, we have learned how to solve simultaneous equations using the substitution method. That's all for today's lesson. Until we meet again, it's goodbye.